Hello everyone, so welcome back. So we are gonna continue with MathCON practices. So this is number 8. So digit 1 through 9 are placed in each circle placed between 12 pencils. We have like pencils right here. And any number placed at the leaf of a pencil is larger than the number at the eraser. Okay, so like if you are wondering what that leaf means, it's basically tip of the pencil. Okay, that's our leaf, okay? And this is the eraser part. So the eraser part should be larger than the tip of that pencil. So that's something we are given. Example, like B is larger than A. So B is larger than A because this is tip of that. So from larger than the eraser, okay? And based on this, what is the sum of the numbers at A, E, and G? So it might be a bit tedious to try to see which one is larger than which and stuff. But the tip of the pencil is larger, right? So like you want to find like some intersection to see which has actually lived more than like the tip, right? So if you look at this F, so the F goes into distraction, distraction, and distraction. So which means F has to be smaller than C, E, and I. And the F actually should be the smallest one because if you look at the other ones like A, B, or any other ones, they have leaf ended like eraser parts, so which means one is gonna be larger than the other for sure. So, but this guy doesn't have any the tip of the pencil. It's just the eraser part. So which is why I'll go with this to be 1. Okay. So that is 1. And if this is 1, like I can go 2 right here to like 2 right here. But if I choose this is 2, then this guy could be 3, but it says like D is going to be smaller than this, but this is 2. This can't be smaller than 2, which is why we cannot go to distraction. And the same idea, if I go 2 right here, like if this is 2, then this guy should be smaller than this guy because the tip is larger. So it doesn't work either. So only way that will work out is going to be if this is 2. So 1 is right here, 2 is right here. So, and then I just can use only 1 through 9 only once. So that means I should have 3 right here. So this could be 4, but this could be 4. So if you take this is 4, right? So 1 and 4. So 4 is larger than 1, which is good because the tip of this pencil is 4, larger than 1. That's good. But if I choose this is like 4, then I should get something right, like maybe 5 right here. But this guy should be larger than this. So which means this has to be 5 or something else. But if you try listing the other way around, so it doesn't really work well. So then I'll take this 4 out of that point, okay? So if this is 3, maybe I can choose 4 right here, and then I can go with like 5 right here. And I could choose 6 right here or right here, which we'll see, it doesn't really matter. So if I choose 6, this guy, okay, and like everything so far so good, right? Because the tip of this pencil is 3, the eraser part is 2, which is good. And if you look at all other numbers, it's the same like case. So then let's take this is 7. And so 6 is the eraser part of this pencil. The tip should be larger, the lip of the pencil basically. And this has to be 8. And this is going to be 9. So let's make sure that every number does satisfy the given condition. So the lip of the pencil is larger than the eraser part. So the 7 is the eraser, the tip is 8, which is good. And in this case, let's say 5 is the tip of the pencil, which is the leaf of the pencil, larger than the eraser of the pencil, which is 4. So if you look at the all others, that is actually correct. But if I swap 7 and 6, that does also work. So if I take this is 7 and this is 6, so that does also work, but it doesn't matter for the question because we are looking for sum of these 3. So A plus E will be the same sum when you swap those, so which doesn't make any difference, okay? So 7 and 6 and G is 4, so that is 17. So that wasn't too bad, but this was slightly challenging. Let me check. 6, 17. Okay, so that looks like that's our answer. So here's a number 9, which is a geometry problem. So we are given a half of the sphere, which is a hemisphere, and there is a part of the hemisphere actually cut it out, and we are given the 90 degrees and 120 degrees for the piece was cut it out, and OK, which is the radius of the sphere, is 6. So if that's the case, OC is also 6, and OD is also 6. And the surface area of the remaining part. Like, if you remember, the surface area of a sphere is equal to 4 times the area of a circle. If you are wondering why, there is a nice videos on YouTube, so you can check for those. And that's the surface area of a sphere, right? But we have half of them, so we should take the half of this guy to find the like this curve area. So if I take that curve area, which looks like purple, so I'm gonna say the 2 times pi times the radius. Radius is 6, so that should be 6 squared. So that will be equal to like 36 times 2, 72. Okay, but this is the curved part when you have fully covered like hemisphere, right? But we do have some part was cut it out, so we don't have really like 1/3 of that surface area because we are given only 2/3. So which is why I will multiply this 72. Maybe I should have done right here. So let's do this right here. So 2/3 of this. If I do that without really doing this calculation, so I can cancel 36 by 3, which is 12. 12 times like 4 is 48 pi. Okay, so 48 pi is a curved area basically, like the purple region that we see. But now we do have a bottom region, which is a like part of the circle that is also now a surface area, right? So let's keep that as well in mind. So if I do need to find this region, which is the bottom of the hemisphere, and since we took the 1/3, 120 degrees part out of 360, you just have 2/3 of the full circle. So 2/3 times pi times radius squared, which is 6 squared. 36 divided by 3 is 12, times 2 is 24. So you do have 24 pi. If you add this to this, that will be 72. 72 pi, which looks like choice A. But the problem with that, there is like another areas that we should also consider, which is the like quarter circle on this part. Because when we cut it, so we do make another region that is also part of the circumference, like surface area. And this one is also another quarter circle that should be added. So if you combine these two, which is 2 of those like quarter circles, which is 1/2 quarter circle, I mean 1/2 circle, pi times radius squared, so that is gonna be 18 pi. So if you add 18, 24, and 48 pi's, so we will get 90 pi centimeter square. So I hope that was clear. So we just use the surface area of a sphere, but it was cut somehow. So we just need to consider all different kind of faces that is gonna be in our new shape. Okay, so that was number 9. So number 10 is a sequence problem. So let's take a look at. So it says A of n, A subscript n, is equal to this expression. That's the general term of the sequence, meaning that whenever you plug for number n, that will be term number. So A sub 1 will be the first term and continue that way. And if 10 over 3 is one of the terms of the sequence, what is the next term? Okay, so we don't really know any terms yet, but we can easily find it, right? So you can start maybe like plugging in n equals 1. Like if I just go a equals 1, I mean n equals 1, then a1, which is gonna be our first term, would be 1 squared plus 1 over 2 times 1 plus 1, which is gonna be 2 over 3. So this is the first one. If I choose n equals 2, then you will get the second term, which is a sub 2. is equal to 2 squared plus 1 over 2 times 2 plus 1. And this is 5. And then this is also 5. That's equal to 1. So you can continue in this until you hit this number, but you never know you're going to hit this number really like soon, which is why I wouldn't bother myself doing this one. I'm just trying to show this because if you have no other like ideas, you can just continue doing this and then wish for some luck. But here's what we can do instead. Like we are told this is one of the terms, right? Then that means when you plug n for this expression, the result will be this. Let's say that's the nth term, right? So then I will say 10 over 3 is the one of these terms, which is equal to n squared plus 1 over 2n plus 1. And then if you were able to get this, but you couldn't solve this equation, you can still use the first approach I mentioned. But let's do now cross multiplication. So you will get 20n plus 10 equals 3 times n squared and plus 3 times 1. And if I pull everything one side, so you will get 3n squared minus 20n. And if I subtract 10 from both sides, so you will get minus 7 equals 0. So the reason I'm doing this because this is a quadratic equation, and then I'd like to solve for that variable, and then I can use quadratic formula if I want to. But let's try to see if we can factor this before we attempt quadratic formula, right? So if I like to see it like 3n squared, if you want to multiply 3n by n, so you get this term, but I need to get negative 7 when I multiply the number right here by the number right here. But at the same time, middle term has to be negative 20, which means I should multiply 3 by the number right here and the number right here and by n and combine to get negative 20. It looks like we need to multiply 3 by 7, but to get negative 20, I should have this as negative 7 and this is positive 1. If you extend it, you are going to see this is exactly what we have. And if you cannot really get this factor immediately, I will say you really need to work on factoring quadratics as well, okay? And if the product is 0, then n equals like 7 or negative 1 over 3. So we have two options, right? So we can try to see which one does work. So if n is 7, which means that's the seventh term is this number. So we can just plug n equals 8. So based on this to get the next term. So you will get 8 squared plus 1 over 2 times 8 plus 1. So that's 65. And that is 17. So this is something we already have, that choice A. But let's go with this as well. Let's see. Like can you ask this question, like, can I plug this number into this expression? And if you think yes, I will say it wouldn't be correct. But the reason why we cannot, because the n is in the term number, like first term, second term, 10th term. So it cannot be really fraction, cannot be negative number. Even though this is a solution to this quadratic, that doesn't mean and could be the case for our case, like for our problem. So we cannot take this anyway. So that needs to be seventh term. So which is not too big, like number. So you can just continue this 1, 2, 3 all the way to the 7 to get that 10 over 3. But again, without really doing, we can just get that immediately by doing this in the first place. Okay. So I hope that was clear. So that was the last problem. I'll see you in the next video.